Today's lesson, we're going to take a look at difference of squares. So this is the last method in factoring that we'll be looking at. So remember, we started with looking at GCF. That was the first thing we learned in factoring, the greatest common factor. And then we also learned about grouping. So remember, grouping is done when you have 4 terms. Then we went into trinomial factoring. That was yesterday's lesson. That's when we have 3 terms. And today we're looking at difference of squares. And difference of squares will work when we have 2 terms. And when does it work? Well, the name kind of gives us a little bit of a hint. The word difference means subtraction, and square means we'll be dealing with squares here. Okay. So before we take a look into what difference of squares is, there's an investigation on page 347 we should first take a look at. So this is continuation of our trinomial factoring. So here we have a trinomial, and if you remember, the middle term is the one that we look for the sum, and that's what they're writing over here, that the sum should be -6, and the product is our last term, which is -16 here. So we're looking for product of 16. So we're looking for 2 numbers, so 2 integers, that will add to become -6, but they will multiply to become -16. Okay? So those come out to be -8 and 2, +2, right? Because when you multiply these two, -8 times +2 does give us -16. And when you combine them, they will become -6. So from yesterday's lesson, we should know that this would be written as x minus 8 and x plus 2. Okay? We don't need to do this, but if you were to expand it, you can always see that it comes out to be this middle term. So I'm just going to expand it to see how that works, right? So I'm going to expand these and bring them back into the expanded form to verify. So that becomes x squared, +2x, -8x, and -16. So you can already see the product coming out. So x squared minus 6x minus 16. So yeah, that is right. Okay. So similarly, if we go into the second example here, we're looking at a sum of -15, but a product of -16. Okay. So here -16 and 1 will work because it will add to become -16, but multiply to become, add to become -15 and multiply to become -16. And once we write them in a factored form, it will be x minus 16 and x plus 1. You can expand this one again to see what the full form here would be. Or you can use these numbers to set it up. Okay? But I'm just going to expand it because this will tie into what we're going to do next. So when you expand that, again, you get x squared plus 1x minus 16x minus 16. And the middle 2 terms obviously will combine. So this will become my trinomial right here. So far you'll notice that we do have terms in the middle that we're combining to give us that sum, right? So same happened here. Okay. Now next example here is a little different here. So you'll notice the sum is 0 and the product has to be -16. So we have to think of 2 numbers that will multiply to give us -16, but they will combine to become 0. So basically they have to cancel each other out. And we only know one scenario when that happens, when one is negative and one is positive. Because if you were to combine them, -4 and a +4, we know they do add up to become 0. But a -4 times a +4 will give you -16. Okay? So when you write them in a factored form, you would write them this way. Now, what I want you guys to notice is what happens when we expand it out. Okay? So when you expand this scenario, so notice that you have one negative, one positive. That's important here to notice that we have the same number, one negative, one positive. Doesn't matter which one you write first, the negative or the positive. But when we expand it, notice what happens here. So one will give you a positive 4x and the other one gives you a negative 4x. And it will multiply to become negative 16. So a few things I want you to notice here. You always get one positive, one negative. And then you will always get this last sign to be negative. Okay, so what happens with these? These will end up to become nothing, 0, right? And this will be negative 16. So there's a pattern here. The middle terms always cancels out, and the last term is a negative 16. Okay, so what happened here is for this kind of scenario, our sum in the middle was 0. So we had two factors. The factors were x minus 4 and x plus 4. Okay. What happens if your product is negative 64 and the sum is 0? Again, this is always the square root of this number because that's the only number that will multiply to become 64. So this answer was 4, which is a square root of 16. This number is 8, which is a square root of 64. I'm not taking the negative, just the number part. And what would happen here is my factors will become x plus 8 and x minus 8. I on purpose just switched them to show you that that doesn't make a difference. So when you multiply these out, guess what's going to happen? Again, I want you to notice the same thing that happened here. This multiplies to become x squared. This multiplies to become negative 8. This becomes positive 8x, and these two multiply to become negative 64. Do you see the same thing happens? The middle two terms will cancel again, and the last term is a negative again. So what happens here again is you're just left with x squared minus 64. Okay? So again here, if I have 25, I know that can be a negative 5 and a positive 5. And that will become x minus 5, x plus 5. And I'm not going to even do this. I know this will become x squared minus 25. Okay? Because the middle terms will cancel out and the product has to be 25. So what does this really teach us here? It actually tells us that when you have two terms and they're both perfect squares, like the x squared, and this is also a perfect square, they will break down to x minus 3, x plus 3, because the product has to be this number. Okay, so the way I do that in a shorter way is I take my two numbers and I first check, are these both perfect squares? Meaning, can I take a square root of these? So if you can, then we're good. So the x squared is x. And can I take a square root of 49? Yes, it's 7. And one would be positive, one would be negative, because that's the only way this middle number can be negative. So you can only do this if you have perfect squares. That's where the word square comes from. And they have a subtraction sign in them. And that's where the word difference comes in. Okay? Because whenever we try to have these factors multiplied, we know the middle term will cancel out and the last term would be a negative of those two numbers multiplied. Okay? So first check, can you do difference of squares? So the first check is, can I take a square root of these two numbers? Yes, I can. Is this a difference, a subtraction? Yes, it is. So that means go ahead and we can do difference of squares on them. So square root of x is x. So you write it in two brackets. The square root of 36 is 6. And you put one negative, one positive, and you're done. Okay. So we're going to do some other examples. So we can do these ones very quickly again. I can do square root. Square root of x is x. Square root of 1 is 1. 1 negative, 1 positive. Again here, we have a. And then that's the square root of a squared. Square root of 100 is 10. one positive, one negative, and we're done.